Are you still with me? Okay. So before I move on, and I'm going to get to the part where I show really nice project pictures, which you will all which the architects are going to like. But before I get to that point, I want to pause here and sort of reflect and summarize what I just said, because I know it's a lot of statistics and words and stuff. And I want to do so with this quote. This is from Kevin Andrews, who is the Vice Chancellor of UNICAF University. And in this quote, he is estimating, and he's saying, look, if you look at the amount of youth that we have, and I showed you the graphs with the numbers and the jobs that needs to be created, if you look at the amount of youth that we have, and if we were to say everyone has to go through what I showed, the previous timeline of education, pre-primary, primary, secondary, tertiary, and then go into the workforce, if we're to say that is how it's supposed to be, and we say, okay, this is how it's going to be, let's build enough schools. Here he gives an example of universities. Oh, the quote is gone. But he gives an example of universities, and he says, say we put everyone through this path. What do we need to do for that to work? And his estimate is that, I need to read this because it's incredible. His estimate is that Africa would have to build at least, yes, we would need to build 10 universities per week. Every week, we'll need to build 10 universities for the next 12 years. And each of those universities would need to enroll at least 10,000 students, which means you build 10 universities for 12 years, every week for 12 years. And each of those universities has to enroll at least 10,000 students every week. You understand? When the first time I read this quote, it was in an office meeting, and I laughed very much. One of our engineers took out his calculator and started doing the maths. And the truth is that it's not possible, and that is the challenge. We cannot, even if it was possible, even if we were able to build all these universities, if the government cannot support them and fund them, we are adding a problem, because the region already has chronically unfunded institutions. So in this context, he was actually proposing online learning as an alternative approach, but even that we know has its limitation, especially in the African context where we have limited access. Many people have limited access to internet infrastructure. And so what we are saying, really, is that the African context demands innovative education strategies beyond traditional universities and classrooms. And that this challenge is far too big for any of us, me, architects, policymakers, everyone, to still be working in isolation, to think that they know it all and they can fix it themselves. And as designers, for now looking at ourselves, we should be seeking opportunities to engage in ongoing conversation with different thinkers and innovators around solving this issue. So I'll browse through these projects quickly. These are three projects that we did in the past years. The first one is RICA, and all three of them has one thing is in common, is that they are reimagining what learning looks like, what it means to learn, and what it means to create learning opportunities for the African youth. The African leadership, the Rwanda Institute for Conservation Agriculture, RICA, was built. Can you still see it on the? Can you still see the slides? No? Okay. They will come up. It's beautiful. So the Rwanda Institute for Conservation Agriculture campus was built with a mission to prepare the next generation of entrepreneurs who will solve Africa's agriculture issues. And their curriculum features smallholder firms for first-year students so that they can experiment and learn hands-on all agriculture concepts. So at the campus, the way the campus is built, all first-year students are broken down into groups of 21 students, which are all required to take care of a 2.1 hectare farm and some livestock. This allows the students to immerse in the experience of a small farmer. And by involving design thinkers in this vision, the campus was able to be tailored to its curriculum. And on this slide deck, the next slide deck, you could see a layout of one of their enterprises, the dairy enterprise, where third-year students engage in hands-on production of dairy products. And the strategic layout connects pastures, animal barns, processing areas, academic buildings, etc., to really enhance the learning process for these students. The campus landscape also, I don't know if you have a good picture, maybe not, promotes, ecological preservation, which exemplifies the Institute's curriculum. Just to say an example of reimagining classrooms, reimagining a classroom beyond just a few walls. The next project, and I'm sorry I'm rushing through them, my 5 minutes I think are over, is the Diane Fossey campus for the Ellen DeGeneres campus for the Diane Fossey Gorilla Fund. This project is not an education, typical education campus. This is actually an example of where design collaboration with innovators across different sectors can create opportunities for learning beyond traditional classroom. This purpose-built campus was to serve to amplify the Diane Fossey Gorilla Fund's mission of conserving and studying mountain gorillas. And so by immersing ourselves as designers in the lives and the thinking processes of these passionate conservationists and researchers, we were able to design a campus that embodies their mission, but also provides learning opportunities for surrounding communities. There's a picture. Is it moving? Okay. So since they opened, I don't know if you've seen the numbers. They've received many guests, but surprisingly, okay, I'm on the wrong. That one. So since they opened, the campus has hosted more than thousands of visitors, and this number includes 7,000, I think, local students, and has included different trainings for different groups of people, and learning opportunities for many university students. But what this shows, imagine if you're a kid living in northern Rwanda, it's remote, and you live close to these animals who are said to be in, endangered. And there are people around you that are doing work, conservation work around it. You would not get an opportunity to learn about the work that these people are doing until you get to at least beyond your secondary school. That is when you can start to learn about, truly, in a classroom, learn about conservation and the work around it and all of that. By providing these different features in what was originated to be just an office and a gallery, we are providing opportunities for these local youngsters to learn about the work of conservation and to hopefully stir up and cultivate their passion for conservation. I'll jump quickly to the next one, which is the North Kinkigali House. This is an entrepreneurship hub, the biggest of its size in Africa. And maybe I'll just mention this quote from Davis Nzijayo. Young entrepreneurs face challenges of finding supportive facilities and being able to connect with like-minded innovators, especially at early stages of their journeys as entrepreneurship. So this hub was designed to leverage shared resources in order to empower these problem solvers with spaces that foster interaction and strong community. And Davis Nzijayo is a founder and CEO of PESA Choice. He's a member of the hub. I think he's now graduated and probably no longer. He says, and I quote, "Even when you're down, the person next to you lifts your spirit." The space is designed to, yes, provide privacy, comfort, identity, and functionality, but really to do what the hub is supposed to do, which is create a supportive environment for startups. So, and this is my conclusion. This is a few pictures of our other projects in the education portfolio.
And finally?
Yes. This is the first to the last slide. What we are saying in this, introspection and questioning of our journey and the practices of the industry is that expanding education facilities in this context, building more schools, may seem like the obvious solution to dealing with the challenges that are presented above. But this is simply not sufficient. We need to also focus on building better. So I'm going from building more, which is number one, to second, building better. We need to focus on building better, creating school environments that are supportive to transformative learning. And we need to learn from each other's experience, as we will do in the afternoon, case studies and all. But beyond that, improving classrooms alone will not solve the continental's education system, not the entire challenge. It will not. And so to truly transform Africa's education system and foster economic growth, we must explore alternative and innovative approaches that can unlock our young people's potential. And so this brings on the need for proactive engagement and collaboration. And as designers, we call upon ourselves, at least at MAS, to engage with innovators and thought leaders in this sector to break these silos. So, putting design at the center and being part of the solution. So our ambition, and again, this is thinking process, and I'd like to hear what you think after this presentation, is we can do 5 things. One of them is leverage our networks of partnership with sector thought leaders to identify needs and define objectives as a starting point. Two is collaborate to research and build comprehensive knowledge base on infrastructure-related challenges that are specifically hindering different forms of learning. Three is championing these ambitious plans through advocacy and partnering for policy changes. Four is expanding our portfolios and continuing to build contextually appropriate designs. And lastly is to, through internal programs of training and capacity buildings where we transfer this experience and knowledge and ensure that what we think are best practices become the new norm in the coming generations. So thank you very much. That is it. I had a video, I will not show it, but I would really like to hear your thoughts and if you ever question your own thinking and practices around design. Thank you very much.
Thank you, Martin. All right, so Martin and Dr. Mark are in the hot seat for the next few minutes. But I'll begin with this, Dr. Mark. There is somebody who is already, in the WU Club platform, and I would recommend you use that because it's easier to pick this than you'd probably walk around. But Frank, let's have the other mic mobile. So someone says, and I like this, Dr. Mark, where they say every year we have thousands of graduates becoming architects. However, who teaches these architects how to run an architectural firm? How to be a better leader and exemplary employer, who mentors the architect, because clearly architecture school doesn't have all this incorporated into the curriculum. Currently, most of the architectural firms aren't taking on interns because they aren't doing well. And even when we, the students, get attached to the architecture mentors, they barely have time for us. They are busy looking for projects to keep their companies afloat. The future isn't looking good for us. Clearly, this is a student, doctor.
There were probably about 10 questions in that.
Yeah.
Professional practice is one of those things that gets left out. I think there's a mistake that we assume that architecture education ends after final year. Unfortunately, it doesn't. I think the UK has made it very clear. They have part 1, part 2, and part 3. Part 3 is where you engage with professionals, and is an actual curriculum where you're supposed to actually enroll in a university, but you're doing work with an architectural firm. So it's an actual curriculum. Problem in East Africa is we don't have that. It's literally a free-for-all. If you get in a good firm, great. If you don't, you're stuck. And that's the frustration a lot of young professionals have, a lot of graduate architects have. And I suspect all the professions have this problem. Medicine doesn't, because you're pretty much going to be employed by the government. And that's actually universal around the world. And until we solve that problem, it's never going to go away. So how do we deal with this? There have been calls in the past to make sure that that professional part, which in the UK is part 3, the US has it, it's the internship program, which is 3 years. In the UK, it's 2 years. That there's an actual curriculum, and in some way it's attached to an academic organization where it can actually be carried out. So the frustrations come because, first of all, we don't have enough practices that can take on students. They don't have the projects to do it. So if you're running small projects that you're literally doing drafting, you don't have the capability to do the professional practice components, and there are lots of them. Another part of that is that professional practice course probably needs to be brought down and filtered through in small components through the entire program. Most times we get to the end, I did mine in the final year of my master's, and it is that you realize, I probably don't want to open a firm because there's too much liability. And because a lot of students don't get that, they go and open the firm and they falter at the first point because they haven't got that experience, they haven't got the legal backing to do that. So again, part of that is because we've concentrated so much on the technical parts of architecture, neglected everything else, that we end up with this problem. We're not actually having a holistic approach to what the role of the architect in society is. So we as professionals, and I'm going to include all the built environment professionals in this, architects, engineers, surveyors, we need a proper internship program so that we engage with our new graduates.
All right, quick question here, any? It could be for Martin or Dr. Mack. So Martin raises, I think Dr. Mack, the problem, even to answer the question, is that the projects should be there. She literally said we need to build, several thousands of universities in, and then she said we need 20 million jobs. You've done the math, huh? 20 million jobs in 20 years, in 2 decades, all right? You've done the math?
57.6 graduates.
57 million.
57.6 million.
Not still enough.
Still not enough. Almost a billion.
All right, so the math doesn't add up. We need to consult the IMF again. Okay, yes, question, yes.
Morning again.
Morning.
My name is Ahabwe Precious Arinda. I'm a student of architecture. So I just want to add to Dr. Olweni's voice about mentorship, like having more than just the sciences, because ideally as architects we are both arts and sciences. Like we are the neutral point between the two. So in order to be able to interact with people, to be able to present to people, we need to be in that space, understand them. What do they go through? What do they need? And we cannot learn that by only sciences. In Uganda, many times you find someone doing architecture because, I have good grades. What should I look through? Civil? Too much of science. Let me try maybe architecture. And they reach there and they're so stressed and they don't understand what they're doing, and this goes to many other courses. So I think we need to take the mentorship down up to the, secondary schools, if possible, primary schools, so that people can enter this space knowing what they want, but also the curriculum should be more diverse to accept. Don't, let a person do a course because they have passion for it. I honestly almost didn't get the course of architecture because I didn't have the 20 points and all that, but I was able to get an opportunity to go to International University of East Africa, which has foundation course or diploma, and I was able to do foundation and start the course, and I've been performing well because I love it. And yet I would have been denied the opportunity if I was trying to get the 20 points, go through Makerere and get stressed. So let's open up opportunities for people who have passion to come into this space, because now you're training robots. They have the minds, they can do it, but they don't have the passion. They just want the money. So let's look into that.
All right. Career guidance. Okay. We have 5 minutes. Yeah, we have 5 minutes. I need to wrap this up. Yes, William, there. One of our people there. Yes. The mic is coming. Can we find a way to cross the mic? Yes. Keep it short and
Thank you, our presenter. Very short. When I had the introduction of the profile and I had no skin, I was very excited because I know about no skin. I've been there, I've seen the space, I've seen how the thing is lively. It speaks.
Yes.
It's just illuminating.
Just you speaking about it makes sense. Yes.
Yes. So I wanted to see that thing and how it will speak to our learning spaces and all that, which I did not see very well. But again, I want to thank the presenter.
In Gabriel, we need more pictures. Huh? All right.
Not really pictures, just connecting, know. Yes. Thank you.
Okay. The mic is here. You want to say something?
Yeah, I totally agree with you. I rushed very much through those slides. But like you said, No Skin was built with the idea of, how do we really support the entrepreneurship spirit? How do we create a space that is truly, truly uplifting for someone who's starting up and stressed, as the other person said? And And that is where you see that, by providing spaces where entrepreneurs can learn from each other. Because no one is standing, if you've been to Noskin, no one is standing every day telling people what to do. It's mostly the entrepreneurs amongst themselves are learning from each other and creating these occasions to, present their ideas, pitch their ideas, get feedback from each other, maybe occasional presenters. But you see how, like, sitting in a space with people that are like-minded, that is designed specifically to that, can help you sort of get your footing and go up as an entrepreneur. So we presented this project and the other two projects that I presented as part of the argument that as we think about education projects or architecture around education, that our thinking should not be narrowed to classrooms and universities and campuses, but we should go around, look at all the innovators, everyone that is doing something to give opportunity to our youngsters to learn and provide our services, be there, proactively offer our expertise. As you were saying, we don't know all of it. We're not experts in pedagogy or whatever, but we know that design thinking can, do a lot in amplifying and making sure that their effort actually come to fruition. And so that is why Noskin was brought up as an example of how that space helps them do that. Yes.
Last one? Yes. Okay, I see two hands. Can we do this very quickly? Then I'll wrap this because we need to go into our very first breakaway session. Yes.
Thank you very much. My name is Hireriana Monica, and I'm a graduate architect. So I'd like to talk about the architecture school and how we are being referred to as very technical, and that's true. And yet, like, actually, when we see how the programs are designed, at least given all the universities, maybe MOOC, Chambogo, IEA, there is a considerable amount of time dedicated to the different aspects, whether the humanities or the technicals. We have the issue whereby this architect actually has to be able to communicate with all the other technical professionals, from the civil engineers, the quantity surveyors, so you are required to understand all that. Yet at the same time, you are also required to understand how the human being operates and how culture actually is at the moment. So even when you're starting the course, you're told that the 5 years are so little for what you are going to have to learn. Like, there is an attempt right now, so I wouldn't want us to really take this as if architecture school is actually not considering these things. But given all that pressure, how do we still make sure that the gaps that we are recognizing are filled? Because there isn't even enough time to take in what we are trying to take in at the moment. So for me, I would like to know, like, how would we practically look into fixing that issue? Thank you.
Dr. Mark, I'll come to you finally.
Thank you very much. Previous presenters, Dr. Mark and Ms. Ngabire. I'm Sandy Stephen Kajumba, I'm an architect, and it's been interesting sitting in these sessions and listening to the discourse that's been going on. I'll just like to paint a picture of my ideal classroom of tomorrow. I see a classroom of tomorrow being specific for different sections of the continent. I've been to parts of Congo where the roads are very inaccessible. But I also know that with technology today, the internet can find you anywhere in the deepest parts of the Congo. Dr. Samo yesterday painted a picture of a place he went to, and which was very remote, and it had its unique challenges. So all the spaces within the continent will have their different challenges. But I know one thing for sure is that the classroom of tomorrow is a classroom that is going to be powered by technology. It's a classroom that is going to be different from the four spaces of the walls that we saw yesterday, from the presentations we saw yesterday. It would be more interactive. It would be more tailored to the dream that we want. But I'm just not sure of what future we want. I don't think from Ngabire's presentation, everybody is working within silos. So there is no seemingly integrated vision towards where we want to go. And without that being clear to everybody who is playing, everybody will keep on working in their different directions. And the status quo is not going to change. So I hope by the end of this presentation, we'll come up with a clear vision of the classroom of the future that we are looking for. And I would like to suggest that in the week lab, maybe before we leave, everybody maybe paints a picture of the classroom that they imagine of tomorrow to help and facilitate Enabel in building that vision. Thank you very much.
Thanks, Sendai, for that input. Just responding to the earlier question, there's a quote which came by from me watching the movie. The book is actually called Victor Hugo, but it's actually worth watching the movie. And I was looking at it because it had something to do with time. But we have to recognize there's actually different times. And I think the quote said there's God's time, there's human time, and there's architectural time. And they're not the same thing. And we need to recognize that as architects. We seem to believe that architectural time is the only thing that matters. But society doesn't operate on that time and has an impact on the way we see things and view things. But coming back to the idea of what we do in architecture school, it's not saying that it's not there. The social sciences, the humanities are not there. Many times it's one subject. One subject doesn't make you an expert. One subject doesn't make what it is work. It's the concentration of what is in there. If you're doing a project where the reality doesn't exist, you're doing a project that doesn't have a site, you make up the site. The first thing that you do in a project is put a fence around it. Basically, what that image is telling me, the graphic image, is that the reality doesn't exist. The site you're doing is flat. It has no slope. Uganda has lots of slopes in there. There's no reality. That's the problem. So it's not that you're not being taught it, it's that it is never transferred into reality. That's the gap that has to be there. So architecture school is not just doing the drawings, that's what I'm saying. That's the technical aspect. It's actually making it work in reality on the other side. And walking around Kampala, you see this. The very first thing that is ever built is the wall. Basically, you're saying the world doesn't exist. The building that I have drawn, not designed, drawn, is the only reality. And then we put palm trees on the drawing and car parks. So, it's tea time. Am I taking your job? So, I'll pass it back to the MC. Thank you.
Thank you very much. Did you want to have a last word?
Yeah, only to acknowledge that what you're saying is true. Sorry, I did not capture your name, but what you're saying is true, and I don't want us to simplify it by saying that we can, in this one conference, all agree on what, the classroom that we need. All I know is that there are going to be different types of classrooms for different needs of people, and we, the different players and stakeholders in the education system, have to realign ourselves and work together and make sure that we are supporting everyone of I think it was 144 million, get what they need out of education. And that is a huge task. That is why we say it cannot be just mass and whoever claims to be, great at these things, have built how many schools. It has to be all of us. It has to be proactively, all of us seeking each other out and asking, what are you thinking? Can I think with you? Can I help you? Can you help me? And that is what we are advocating for, and that is what we're trying to do. Thank you.
All right, thank you very much. Can we once again appreciate Dr. Mark and Martin? All right, so my breakaway teams are here. They will be joining us very quickly. We'll do this. I'm hoping this time they'll manage the time better. So, Meryl? We are doing about, how many minutes do we have? 50. So let's say your coffee will be at exactly 11:10. Okay. 11:10 is when we will have coffee. In fact, just so you can get uncomfortable in the breakaway session, coffee will be available from 11, right? Just to make you uncomfortable while you're there, so you can conclude as quickly as possible. So we have 3 breakaway sessions: community practice, innovation construction concepts, and participatory design, incorporating technology into schools. So the auditorium will have the second one, innovative construction concepts. You remain here, right? And so community practice, you're following him. We are going to the blue room in primary, all right? And who's going to yellow? And incorporating technology into schools, there. You're going to primary yellow. So you follow Feni, okay? So Feni is with incorporating technology into schools. That's the yellow class in primary. So Feni, please make your way. They'll follow you. And then we'll have a community of practice, which is where we're, Nobat is heading the blue room. Please follow him. That's where Peter Tumhechi will be. And also we have Mike Chironde. And then here in the auditorium where Meryl is, we have Engineer Edson Agume and Architect Felix Holland. In the yellow room on the other side, we have Edgar Kalema and Engineer Emmanuel Senjiyumva. Please go. From 11, coffee will be served. I'm expecting all of us back in this room by 11:30. So 11:30, we are back here in the room for our next session. That's at 11:30. Coffee will be served from 11. Our timekeeper will have assistants who will help him. William, please note that when you have 10 minutes to go at exactly 11, William will walk around the rooms to let you know you have 10 minutes. So each session has 40 minutes starting now. right? Now that we're all here, please feel free to move in front, because you may not be able to see if you're at the back, since this is really about concepts. So if you're going to want to see what's on the screen, there's seats on the front. These are all your seats. And the best part is from here we move to coffee, so no one's going to come and take your seat. Or nobody's going to come and occupy any seat in front of you. So the closer you are to a screen, the better for yourself. And that also helps, you know, for the speakers who will be able to seek you out when you're closer, all right? So I want to hand over to the presenters. All right, we're starting there. I can give you this mic and, all right. Feel free to do your own intros. Yeah, they're going to expand the screen, don't worry.
Well, good morning. I'm Edson Agume. I'm a structural engineer and work for Local Works. I'm also one of the owners and people who started Local Works. My presentation, as you see, is about local and ecological materials as part of the bigger presentation that Felix is going to follow up with. And it is divided into about, I think, two or four segments, depending on how you look at it. And the first segment, I'm going to be looking at basically what is the basis of specifying these materials. And then the next part will be how, basically what are these materials. And I've looked at these materials in three parts, which is we have stone, we have earth, and we have timber and other bio materials. I must have to apologize that the way the presentation is set on the slide may not really match the way I will talk, because I've had a bit of a change of mind this morning on the structure, but it will be fine. I hope we'll follow. So the major basis of using or presenting any material, whether it's ecological or normal material, should be how is this material going to work on a building. The building is designed for, temporary buildings would be, say, 5 to 10 years, but generally buildings are designed for 50, 100 years. But as we all know, they don't just go away, they stay there. But how are these materials going to behave when you use them on the building? And of course, the way they are going to behave is going to be purely governed by how they are exposed, as in the exposure is to water, and water is in so many different forms. You have normal water, rainwater, you have humidity, you have capillary moisture. Water basically shows itself on a building in so many different ways, and you really must understand how your building component or your building on a material on a building is exposed to this. This will help you on how you specify, on how you protect. The other part would be other issues of, if you're using biomaterials, it will be insects. There are big insects and there are also small insects. The bigger insects are more like ants and termites and stuff, and the smaller insects is like fungus, mold, all that stuff that actually causes quite bad deterioration. Then you have exposure to, of course, wind. You have exposure to some of these risks we designed for them structurally, fire, and the chart or the graph that you see there is borrowed from more like the edging effect of timber that is exposed. And the green line, basically when you do nothing, even when the timber is actually treated, but it's exposed to the elements, that is how it is going to degenerate. And this would definitely also affect other materials in the same way, but not to the same degree. So when you look at, yeah, it seems to work. When you look at, say, if this timber is degenerating, you could maintain it. And maintaining it would be either, if this timber was treated, you are going to retreat it, and this would bring back a bit of performance to that timber. But it will reach a time where even maintaining or refurbishing will never really bring back to the design objective of the element, and you just have to replace it. This could still work for any material, but it's just a graphic to basically show you that the way when you put a material on a building, or when you build a building, it's never going to perform the same, especially when you neglect it. It's never going to perform the same next year, and in 50 years, and in 100 years, it's going to degenerate. Then the other is a cycle of, the other kind of decision-making process would be the cycle of how these materials are generated, how they are produced, and how they are actually used, and how they are, basically discarded when you no longer need the building, or when the building is no longer fit for use. And this is quite important because it is going to determine how much energy is in your building, how much embodied carbon is in that building based on the source of the material, the processing required, the distances that between the processing and the erection, the amount of maintenance, the amount of energy you're going to use to run the building, and later on when you actually discard the building, what you're doing with that material. Of course, the best case scenario being that this material is recycled to do something else, either to make, if it's timber, maybe to make furniture, or to maybe build another building. This is basically the problem we are facing, and I am not an expert in it. It's just a highlight to show you exactly that, we are in the built environment, and the thing is that when you decide to build, for sure you're going to release some carbon. That's for sure. We just have to limit how much we're going to release. And this chart basically shows you how much the contribution to the environmental degradation as builders are doing. And it's just something also to be at the back of your mind as you, and basically if you work with this chart behind, as you make the decision, knowing that, there's something harm you're doing, basically reducing the amount of harm that you're doing. This is basically a typical building or a typical classroom block, and not, I don't think these are the materials, but generally in Uganda, a building or a classroom or a village classroom, actually, this is what it is has a foundation, which is normally concrete-based. It has a floor. Floors are normally layers of concrete, and if you're lucky, maybe you can afford tiles to put on the floor, but generally it's a layer of a concrete substrate and a layer of a cement kind of finishing, a wearing course. You have walls either built from burnt brick masonry or block. These walls are normally finished with cement and cement render and paint. If you're lucky, you have a concrete ring beam, and you have a roof, normally steel framed or timber framed, and you generally have a steel roof sheet, normally colored, which may not be that nice. And this is where we are going to kind of deviate a bit and flow. So what materials are we looking at? I said I'm going to look at three kind of different classes of materials or types of materials. The presentation was more made for building elements, but I thought it better for this discussion to actually look at a material as is and how it is used on different building elements, and I hope you can follow in that way. So the first is stone, and why stone? When you go back to the first chart, you will realize that stone is going to behave quite well in any kind of exposure, in water, in with chemicals. It's kind of stable. So will require little maintenance, and that means it can actually be used almost anywhere. And that's why in most cases we can use stones in the foundation and we will not have any problems, because the foundation is kind of the most exposed part, especially here where the soil is always moist. It may have some chemicals, so you want to put something that will respond well to such an environment. Also, the other factor being that most of the stone, if it is in Uganda, most of it is hand quarried, so there's not much energy involved. But I must say that, of course, if you're going to transport this stone for 200, 300 kilometers, because it's a very heavy material, it may not make much sense because you're going to use a lot of energy to transport these materials. And also, generally in Uganda, any place I've worked in Uganda has stone. Of course, there are different stones, but they have stone. So you basically need to see how you can use whatever you find near the location that you have. And where can we use stone? I've talked about foundations. You can actually we have used stone many times in flooring. I actually don't have an image to show that, but we've built many floors with stone, not a classroom yet, but maybe external classrooms. But the other thing that we have managed to do successfully, you heard yesterday that cement contributes about 8% of the global emissions. So many times in a classroom, you actually need a hard surface where you cannot really avoid a cement finish or something similar. So we have used stone successfully in reducing, in combination with concrete, by reducing the amount of cement, even up to 60% of concrete reduction, by layering these stones and basically having the same finish, same performance that you'd require from a floor, and much less cement because of combining these two things. It's easy. Stone can be used for walls. I don't think I need to talk about that much. The other part of stone, because of its resilience, the thin slated stones can actually be used to protect other weaker materials, which we're going to look at next, which is earth. So earth is, in this country there's earth everywhere, and it can be used. Almost every earth can be used, only that the limiting factor would be how you actually use that earth. It is very, very important that you have some good investigations to understand the profile of this earth that you're going to work with. And some of the investigations you could start with visual investigations. Normally, in many parts of Uganda, maybe the single part where I have seen subsoil that is not red. And normally the topsoil is what you don't want to use because it's full of compost and something that you cannot really control on a building. So you want to avoid the top layer of soil when you're actually profiling the earth for construction. So in most cases, and I'm not saying that in all cases the subsoil will be red, but in most cases it will be red. It should have no smell, it should have, things like that. But I don't think we should run away from doing proper profiling of the soil. How much clay, what is the property of the clay that is in there, and what can it do, how much gravel, how much sand is in this, because depending on how you're going to use this will come in quite handy. The biggest, going back to the first chart, I hope you have it in your mind, but I can still quickly go back there, is that soil it will be affected by water in different forms. And there are many ways that we have tried to do to actually counter this, but the biggest biggest issue with soil in construction is water, as moisture, as in many ways. And that's the design in a way needs to counteract that problem. Otherwise, you're going to end up on that green curve, and even 2-3 years down the road, you probably have no building. But where can we use soil? We can actually we can even use soil in foundations. It's not something that we have done, but you can actually kind of stabilize soil for foundations. We have done where you can stabilize soil as a retaining wall with maybe other geoplastics for that case. You can use, most of the time we have used soil for walls. And in different ways, as brick, as soil in compacted soil in formwork that is later removed, which is you call rammed earth, which is what you see there. We have used compacted soil in textiles in these bags. At the end of the day, it's the same thing. It's just the process and how your site and the skill that you have and the money, which is the biggest factor there, will allow you to use that. And also how the soil properties that you have, what will they favor most, and not forgetting the structural requirement that for whatever element for the wall that you're dealing with. My time is a bit short, so I will maybe in many cases where you cannot avoid water getting onto this soil, especially rainwater. In many cases, you need to protect this soil, and this is how the idea of stabilization comes in. Stabilization, of course, it increases the strength, so it can improve the structure bearing. But the most important part of stabilization is actually reducing the damage that water can cause to the material. Again, the kind of protection that you're going to choose is going to be fully guided by the type of soil you have. There are some soils where you can stabilize with cement, some with lime, some maybe with a combination of both. Some some could actually even hold, but it's quite important that you understand what you're dealing with. I think even what you see, which is the fired brick, which is really fired earth, is in a way trying to counteract the issue of durability. You fire the earth so that it's resistant to the elements. Which also reminded me of the fact that even the clay tile is actually an earth roof. I was actually looking for examples of earth roofs, but the clay tile is actually an earth roof that has been fired to protect it from degradation. Earth has excellent performance when it comes to indoor climate. It has excellent performance against chemicals. It has very good performance against UV, which literally kills everything. Earth has very excellent performance for UV. And then finally, we'll talk about, my time is actually gone, we'll talk about timber and other biomaterials, like bamboo is one of them. But timber in general is quite a resource that we are reaching here in Uganda. I was listening to a presentation again the other day by Arop and Gatsby, where this research that has been done in Kenya, in Nairobi, to try to give the case for timber in building construction, even for walls, for floors, for many different uses. And I was shocked that they actually, in their study, the assumption is that all the timber is actually coming from Uganda, which means that if that study was locally done here, it would actually be a much cheaper way to construct. Of course, that study concluded that, with some types of construction, especially framed construction, you're almost there with the normal brick and mortar in cost, which means that here we should be lower because of that. And again, with the embodied energy, the energy kind of reduces by like 30–40%. Yeah, I'm concluding. And yet, and yet there's such amount of transport and logistics involved in moving timber from Uganda to Kenya. And I think, yeah, timber will also, that was what the introduction was, it will behave very badly with exposure to water and insects. So we must detail it well, and we must treat it quite well. More often the treatment, normal treatment systems I see, especially copper-based treatments, are quite of an environmental hazard, especially with the groundwater and the ecosystem. So normally you want to use some simpler metals, not copper. We've been using boron, which is a bit not as hazardous. It's able to kill the insects, but without killing people, so, and other things. So I guess I could stop here, and maybe as we interact in the questions, more stuff can come out. Thank you.
Good morning, everyone. My name is Felix. I'm an architect with Local Works. And I'm going to pick up straight where Edson left us. He ended with timber. And I'm going to make to you a very specific proposal based on timber. That fits well into this conference theme, because it is a proposal for prefabricated classroom buildings. Can we have the presentation? Yes. Those of you who are familiar with Local Works will know that we have spent much of the last 10 years designing schools. In very different locations, for very different clients, for different sets of children. I think many of these schools have created very beautiful learning environments and are very contextually sensitive, but they do have two very important weaknesses. The first weakness is that the construction time of these schools is particularly slow. It is not uncommon for us to work 15 or even 18 months on a particular school project. And the second big weakness is that they are all too expensive per square meter to really be suitable as a model that could easily be replicated at a bigger scale. At the same time, the number of schools that we have built, maybe we have created room for 10,000 children or so, is kind of dwarfed by these sort of figures. I think we've heard a bit of a good introduction yesterday in regards to the real lack of teaching space in this country. UNICEF believes that 1.6 million children in primary age are not attending school. These are even pre-COVID figures, so probably numbers are worse. And the population pyramid of Uganda is, of course, incredibly impressive, so that if 1.6 million were to be missing now, we can only imagine what happens in 5 years from now, when all these currently 1 to 5 year olds are coming online. We have a very conservative estimate there of 25,000 classrooms that are missing today. I think that was superseded by much more impressive figures that we heard yesterday of 8,000 schools, which are 80,000 classrooms that are missing. What's the problem currently? Well, those schools that we have naturally are hopelessly overcrowded. I've seen classrooms with 200 children in them. And then we also have a huge quality problem. It is incredibly difficult to build school buildings in remote locations at a big quantity and ensuring good quality. This photo was taken in a building that was not even 10 years old yet, was funded with donor money, and we basically condemned it because of a continuous crack once through the entire structure. And then we have the issue of climate change. I'm not going to dwell too much on it. You all know about it. We are using high energy materials. Concrete block is the preferred material. We all know what it does. Or we're using fired brick, which is of course the primary reason for deforestation in Uganda. Can we go back? Uganda, I'm not going to dwell on the left one. You have seen this many times now. Some people say 37, some people say 38. It doesn't matter. It's a lot. But Uganda is also a signatory to the Paris Agreement, like all other East African countries. The government has committed itself to reducing its carbon emissions by 25% by 2030. I believe, whilst public infrastructure is not on the government's primary sort of action plan, I believe it is actually a low-hanging fruit because of the importance of the construction sector for the emissions. And our proposal, therefore, is directly basically pointing towards those two requirements. In other words, how can we find a way of scaling up school construction, including addressing all those quality issues that I've just highlighted, and at the same time, can we use it as an opportunity to reduce Uganda's carbon emissions through the use of regenerative materials. We call our proposal eco-prefab, and it is a proposal that is directly focusing primary day schools in rural settings. The buildings are made out of a composite of steel and timber. We are using as little of everything as we can, including steel. Steel does have its real benefits in terms of durability, but we're using it as sparingly as possible. Edson made some point also on concrete. The idea, cement is a very good material, but you need to use it as little as you possibly can. And we're combining that with wood, locally planted pine and eucalyptus from certified plantations. And we are trying to also create at the same time, since we are architects, not just sort of random buildings, but of course we're also trying to create real indoor quality buildings that are full of light and air. What you see here on this image is the teacher's accommodation. The typical village school does not only require classrooms, it requires other buildings, including teacher accommodation. What you see here are some junior accommodation units that we built in Luengo district for the Cotton On Foundation. And probably one thing will strike you straight away when you see that building: you don't see the timber. Why is that? It is because our buildings are actually fully plastered. We do not expose the structural wood, and I'll show you in a minute why we're doing that. And the other thing that you maybe see on these pictures is the color of the finish. We have a little sample outside where you can look at that sort of hands-on. We are not painting these buildings. Our experience when talking to district officials or to ministry officials is that maintenance of public school buildings is a major cost issue. And the constant repainting is basically unaffordable, and therefore we are proposing the use of pigmented plaster where earth is being used as the main pigment. Important, I mentioned, of course, this is all on the context of the climate crisis. We believe that these timber-based classroom blocks have at least a 75% reduced carbon footprint compared to a conventional type of construction. And the buildings are not temporary. They are designed for 50 years, they have a design life for 50 years, they are not demountable, they are not mobile, they are not containerized, they are not shed-like, they are buildings like any other rural primary school building. Sorry about that. How does it work? Very briefly. These walls are all prefabricated in a workshop setting. They are broadly 2 meters wide, 2 meters high, made out of pine. They are erected on top of a concrete upstand. And then on the right photo, you can see an infill block. You can also look at that outside. These infill blocks are made out of sawdust mixed with lime and pressed. These infill blocks are very lightweight, but they give the wall the required solidity and insulation. And we are then, sorry about that, we are then inserting it into the wall frames, applying chicken mesh on both sides, and then finishing it with lime plaster, not with cement-based plaster. There's various reasons for why we are using lime. One of them is that it is a waste product. There's a company called Uganda Oxygen that produce medical oxygen and welding gas, and a byproduct of their production is artificial lime, very pure form of artificial lime, and that is what we are using for our wall finishes. Edson has talked about stone foundations and the, the ability of stone foundation to effectively deal with humidity. It is of course also now beneficial that this building is a particularly lightweight structure, and a lightweight structure means that the requirements on the foundations are relatively reduced. Other aspects of the building are as you would expect it. The roof is very similar to a normal, typical Ministry of Education structure, a timber truss, a metal sheet roof, no ceiling, there's no budget for a ceiling, a simple concrete floor. Edson has explained how thin we keep these floors as an additional measure of reducing cement. And then windows and doors are metal frames with timber plank infills. Unlike, in other words, we are not using glass. This is another maintenance-related decision to work with shutters rather than with ordinary glass windows. All timber is treated with borax and boric acid. Importantly, any treatment that you apply timber on evaporates with time. With exposure to rain, with exposure to air, the treatment efficiency reduces. This is one of the key aspects why we are encapsulating these walls fully in lime plaster, so as to retain the efficiency of the treatment for a very long time. The same reason applies to fire considerations. The 25mm lime plaster produce a very efficient protection of the primary timber subframe against fire. Some people ask us, is there enough timber in Uganda? Yes, there is enough timber, a lot of timber. The output of Busoga forestry alone could construct 4,000 classrooms per year in Uganda. And of course, Busoga is not the only one, but it is currently our preferred supplier, given that they are certified. We are in a rollout process. We will offer all buildings that are required for rural schools, various classroom configurations, various teacher accommodation configurations, an admin block, a toilet, and a kitchen, all prefabricated and erected on site in a very short period of time. Cost-wise, we have been reminded by the country director of Enabel at the beginning of this conference that cost is of the key consideration. These buildings will be cheaper than what the Ministry of Education currently builds by about 5%. The cost reduction, however, is actually higher because of two additional factors. One, the construction period is approximately factor 3 shorter. And of course, as you know, the time of constructing also costs money through supervision, especially preliminaries, etc. So of course a prefab solution is faster and therefore cheaper. The second cost reduction will be in the maintenance over its lifetime. The constant repainting will not be a requirement. Last but not least, before I go there, I wanted to actually show this one. Sorry. Where are we right now? We are rolling this out in steps. Sorry, this thing is not working. We have started with teacher accommodation. We have built 52 units for the Cotton Foundation. They can be visited by anyone who wants to see the technology, only that you need to be willing to drive 4 hours because it is in Rengo. We are currently in a situation where we are preparing to build a pilot classroom block, hopefully much closer to Kampala, because we are aware of the fact that any new technology, any innovative proposal requires a hands-on, something to touch, so that you can really see and explore and have a proof of concept. Once we are further with that, we do hope that we can roll this out, and we do hope that we can, contribute to a productive solution of this problem. Thank you very much.
Thank you, Felix. You've actually been exact on time, and I'm actually still going to leave you with the role of facilitating the discussion, since we are working together on the conference.
So I'm going to facilitate my own discussion. Who wants to ask a question? We have one here.
Thank you. I'm Robert Kato from the Construction Management Unit. Maybe we have discussed before, but still, I insist we want to see something like a lab, an ICT piloted, because it has water installations and what. So maybe when you are piloting, please, because like talked of a seed school, we have those special buildings in a seed school, the lab and the ICT, maybe the lab, because it has water, the electrical installation, everything. Please, because we are not sure of your water piping and what in those walls. Thank you.
KISU Sam Smith from Construction Management Unit, Ministry of Education and Sports. My take is on the seismic areas. The Western Belt, we really experience a lot of earthquakes. So I don't know about your technology, whether it could withstand that kind of dilemma.
I will respond to the first question, and Edson will respond to the second one. As I had explained to you earlier, we do not think that this proposal would not be suitable for secondary schools. It is. A science lab is not specific, not particularly different from a normal classroom. It tends to be bigger, it tends to have a prep room, and it has an element of plumbing. We took a decision to focus on primary schools first, but we do have in mind that at a later stage of this product, we do want to also, of course, answer the problems of secondary schools, which are not only science labs. Accommodation is a big one. Many of the secondary schools require boarding facilities. They are also very costly buildings, and we believe that prefab can offer very important answers there as well.
Thank you. For the prefab, what Felix presented, we have checked this thing against the design against moderate earthquakes, and it performs quite okay with quite very high wind speeds of 30 meters per second. So the current concept is able to perform in those conditions. There's of course scope to check for higher seismic zones, and you have to understand that for sure the far west, where you are much closer to the epicenter, you're going to get much higher a possibility of earthquakes than like here in Kampala or in Ruengo where we've been working. So there must be some other things that should be added within the structure that should counteract that. But what you must understand is that timber, with so many connections, with so many nails, so many screws, will have so many areas to release the energy. So even if it is overrun, it will not collapse because it has so many energy releases that will eventually reduce the effect of the earthquake on collapse. And for earthquake design, you're really trying to not maintain the structure. You really have to allow that you're either going to replace or repair the structure, but you're trying to save lives. Because it would be so uneconomical to design for, say, 3 meters per second acceleration, which we expect in the far western region. You will never afford the building. But I think the thing should be that you actually save people, and maybe you can renovate the building or repress the building. Yeah.
We have another question here.
Thank you very much for the presentation. I'm Mwangzi Samuel. My question is on majority of the buildings that you've been presenting are on the ground floor, basically. So let's say, for instance, we have now a storage structure, because yesterday we talked about adaptive classrooms, so we're expanding vertically. What design solutions would you have for the slab and also the foundation?
So I assume this question goes to the first presentation, not to the second presentation, because both. On the second presentation, that is specifically really, as I said, it's targeting rural day primary schools. So it's specifically not intended to be a multi-story proposal. I guess in terms of a more general question to how can a multi-story building utilize alternative local materials, I think one of the key answers has to be in the material that is being utilized for the infill. If you do 3, 4, 5-story structures, I think we are going to be for quite a while limited to concrete frame structures in Uganda. I think we are still quite far away from mass timber here. But I think there's a lot that can be done in the infill. Which type of materials? Edson has mentioned some of the materials. So in other words, earth-based materials are very suitable for wall infill. But even these timber frame models that we are presenting here for the eco prefab could also be very, very interesting for facade infills as materials. I don't know whether you want to add anything to sustainable materials for multi-story structures.
I guess what I would want to add on is the fact that this is a presentation. Of course, Felix's presentation is about the technology, but for me, my presentation was about the materials. It does not mean that you don't design, because the material is just a response to a design. So you should be able to do anything as long as you understand the limitation of that material. So you should do anything, in my view.
Okay, thanks very much. Thanks, Felix, for that presentation. I am always interested in innovations in technology. Now, these panels you created, I'm just interested, have we done any acoustic and thermal performance analysis on what they are?
I'm going to collect 3 questions. I saw one there.
Thank you. Manif Isaac, student architect at the International University of East Africa. My question would go to the first presenter. He spoke about different materials. This is in terms of treatment. With timber, it is across, in particular maybe in Uganda, treatment of timber is quite clear. But when you go to the earth, for example, the soil profile is different in different regions. So my question here is maybe if you'd highlight on the extra detail that you take, because you realize that they hold different strength, yeah, because of the different profiles. So I don't know, like maybe if you go in different areas where the soil is of low strength. How do you deal with that? Thank you.
Can we have the third question?
Yes, my question is about materials. When we talk about using bamboo as a construction material, it sounds like a myth in Uganda. Could you shine a light on it?
Okay, those were the three questions. Have we done acoustic and thermal studies? Not yet. We are waiting for the pilot. That will be one of the key functions of the pilot classroom to evaluate all these performances. Do we expect it to do quite well? Yes, we do, because we have built this type of classroom many times before, so we have quite a good understanding of how it works. And amongst others, this pressed sawdust lime infill block will perform very, very well as an insulator. So we are quite hopeful on that. Edson, you should respond to how you deal with different soil qualities. That's how I understood the question.
Yes, thank you. I believe the issue should start from what are the performance parameters that you're looking for on that kind of, whether I assume it's a wall, on that wall that you're designing. What kind of strength do you want to achieve? What kind of exposure is it? Is it an internal wall? Is it an external wall? And then when you look at the profile of your soil, you may realize that after doing some tests that you're not going to achieve what you want to achieve, even when you chemically stabilize this material. So in many cases, we are blending these materials with gravel, we are blending these materials with sands, but you profile the material so that you properly understand what you're looking for and what you're missing, and you replace what you're missing. And about the myth of bamboo, yeah, I would agree with you a bit, but we have used a bit of bamboo on temporary, what we call temporary buildings, but we've still gone through so much testing. Bamboo is a very, I mean, even within the same location, even within the same cluster, you're going to get so much variations in properties. So and the fact that we haven't used it a lot and we don't have so many people around who have used it a lot means that we are working in the dark mostly. But yeah, we've done a structure. It's an exposed structure actually. I'm not sure that it's in a location where you can visit. We have also done profiling of one of the most commonest bamboo here, which is the Bambusa vulgaris, and we have a textbook of all these tests of these results that you can use if you want to design, and I think we can share them for free. Yeah.
As we have come to a close, I just wanted to make one additional comment to that question or that response from Edson. It is very important that for anybody working with natural materials that we use serious science and engineering. I think the whole industry of working with green materials is not helped by not taking this seriously and by doing stuff. Most of you have heard of the Mukwano wall. Anybody who is presenting any idea with compressed earth in Uganda is being always told that thing doesn't work because of the Mukwano wall. Why was that? Because it was badly done. Engineering knowledge was not used when this mixed design was done, if there was at all a mixed design. So the same systematic scientific approach that is being used for any concrete works before any site starts needs to also be applied to when you work with natural materials, be it earth or be it bamboo or be it timber. And that is really something that I want to make point out very clearly here, that just using it easily without thinking much about it and without seeking expertise can actually be really detrimental to the whole agenda of nature-based solutions. I'm told we are coming to an end, and we have coffee now.
Yes, very sorry, Felix. I know we're all enjoying the discussion, but Architect Felix and Engineer Edson are still with us throughout to the end of the day. They also will be exhibiting a bit of the work, so we can continue the discussions during the teas, the break, lunch, and in the cocktail time. So thank you all, and you're all welcome to have a cup of tea. And let's make it very fast. How many minutes are you giving us, Mero? Because we need to come back to now receive the guide and, yes, have the next events. Thank you. Thank you, Edson.
All right. We should be able to start in 4. Hopefully, it should be actually 3 minutes. So we are trying to get people in as fast as possible, and let you know that we'd like to start our 10th session for this late morning and early afternoon. We'll then move from that 10th session to the 11th session, which is the case studies for the schools, and that will then lead us into lunch. But I want to prepare you that since we've had quite a good coffee break, we may have a late lunch, or at least lunch won't be at 1 p.m. clearly. We'll try and see how early we can have lunch before 2 p.m. So our very first session, this late morning and early afternoon, will be introduction of the draft school design guide. If you've had a chance to glimpse at the draft guide, there were copies around this room. You may have seen 1 or 2, and you may have run through the guide. But Professor Peter Clegg will, and the team, including of course Meg Collin, will run us through the guide. And then, but also that's so difficult for Meg. How many pages? And we're saying 17 minutes for. So 234 pages we must look at in 17 minutes. All right, that's a. Do the math. How much time for each page? All right. Again, so welcome back. Encourage your friends to come back. I see Meryl is making quite a couple of kilometers, while she tries to get people back into the room. All right. Anything exciting from the breakout sessions a short while ago? Do you want to share? I can start with you. Yeah. I would like to get some notes, since we were not all in the same room. If you want to just share in 1 minute what it is that was your key highlight from, say, session. I think that was 8.2, which was in the auditorium. Anyone was here in the auditorium? We were looking at concepts. Anyone? Here, this is an architect who clearly was in this room. You must have stayed here. What was your highlight from this room?
My major highlight is how we have been shown how natural materials can actually work, but then also mostly how they are making it possible for a certain part of our society receive services. Yeah, so like people who don't have so many resources, when we resort to our local materials, then we actually get to have solutions for them. Thank you.
All right, finding local solutions to our very own, communities. All right. Anyone was in the yellow room? We're calling it the yellow room, but it's the primary section. Yellow room in the primary section. Anyone was in the yellow room? Meg, as I wait for Prof. Is Prof having 2 coffees on me? I thought we allowed him 1 coffee. I don't know why he's having the second coffee. And I want to welcome Josephine. Josephine is back. Madam President, you're welcome. Thank you for joining us. Jacqueline. I don't know why I keep calling her Josephine. Jacqueline. Apologies. All right. Jacqueline, welcome. Madam President. All right. So the yellow room had technology into schools, incorporating technology into schools. Yellow room. Anyone wants to share the highlight? The room was full. I'm surprised no one wants to say anything. And that room was extremely full. I remember coming and all of you were clapping for the presenters. So clearly they said something nice. Yellow room. Any volunteer? Okay, as you think about it, those of you in the yellow room, let me go to the blue room. Okay. Blue room, any volunteer? I think I should have just been grabbing people. Okay. And I know we are running out of time, so I don't have too much time to... Okay. Commissioner, you're welcome. Thank you so much for joining us. and we will be expecting other VIPs shortly. So, blue room, who was in the blue room? Yes, highlight from the blue room. I like that you are the, no, you can't be the one. Just identify one of the active students in the blue room, and I will walk there. I want to see if they were attentive. Just tell me, yeah, Prof. As soon as you're set, I'll kick it off. Who is the very active one? Just pick for me one who was active, and I see if they remember. No, I'm looking for the student. Brown t-shirt, brown shirt. That student there. He was very active, huh? Okay. Let me just walk there so that I find out. I'm coming to you because they told me you're very active in the class, huh? That one there in the blue room. You are the one. And who are the panelists in the yellow room? I need them to identify their students. Key highlight from your session, your breakaway session.
The key highlight I can say was how they do manage the schools with the school policy and how they do manage the business, because it was the community practice. So it was the key policies, how they do the schools and how they do manage the business. So it's what I gave from the two presenters.
I was about to say, are you more comfortable in French? I could get a translator, you know. You can speak French? You want to say what you wanted to say in French? I would have looked for a translator. Meryl, would you help me on that if the French was there? Okay. All right, so let's quickly dive in, but thank you. Yellow is the only one missing in this conversation. So Meryl, I think we will, when we are awarding performance, yellow doesn't fare well in the performance appraisal. All right, so allow me move on to our very first session for this early afternoon. We are looking at the introduction of the draft school design guide. And Prof, while you're away, I mentioned you have 17 minutes to tell us what's in the 234-page draft. Yeah, right? So Commission, imagine they must summarize 234 pages in 17 minutes. But Prof, I'm told you're very good at summary. You did it yesterday, so I'll allow you and Meg just do your thing. So ladies and gentlemen, let's welcome Professor Clegg, and of course Meg will also join him a little later.
Yes, okay, you can come up. Hi, let's go up here. So, well, thank you very much again, and I'm not going to say much in this session. You heard me yesterday, you probably heard enough of me, and there's no way I can summarize all that in such a short amount of time. But I am going to let Felix know that he is going to come up at the end of this session just to say a few words. And I'd just like to say that, I've just come from a very energizing session on the community of practice, and with one of our trustees, Mike Kironde, all about making new schools and improving education in Uganda. And it was very, very good to hear from teachers and from school proprietors, and Mike reminded us that what we heard at the beginning, that 75% of schools in this country are not private schools. And I think it's really, really important. I think almost to say that if there is another session about school design after this, they should be welcomed more. The private sector probably needs to be welcomed more into this conference. But just to go back to where we were, where we are with the school design guide, I'm going to leave Meg to talk through with you what we have been doing over the last 6 months and refer to the collaborators, many collaborators that have contributed to the design guide so far. It is in a draft form. We do need your feedback. We want everybody to own this, and we want to know from you how relevant it is and how you will use it. And I'm just going to hand over to Meg to take you through the process.
Thank you, everyone. Hopefully you can see the slides okay. Just to briefly show some of the team who've been working on this, who are here today. Hopefully you'll have a chance to meet them in person if you haven't yet. This is a brief timeline which gives a picture of where we have been over the last 2 years and what has brought us to today. You'll see we're near the end of that timeline, and we're hoping to do a final set of consultation with you all here, and then launch the guide later this year. From the beginning, it's been a work of collaboration, and these are just some of the people who we've been working with in East Africa, who have been instrumental in the development of the guidance, sharing their time, knowledge, and experience. The fieldwork period involved my visiting over 40 schools in Uganda and Rwanda, taking objective notes against a standardized set of criteria, but also, really importantly, learning from the experience of the staff and the students in those schools. And through these visits, we gained a real insight into the challenges and opportunities facing schools, where the innovative and creative solutions have been found, and how resource constraints can be a barrier to educational facilities, as we've heard a lot about already. Just to take you through the process briefly, we've done desktop studies of national design codes, NGO codes, schools design guidelines from around the world, each time trying to draw out what things seem to be really relevant and useful in this context. We're extremely grateful for the substantial contributions of a number of technical experts, including Grant Associates, who wrote the landscape section, and Ollie is here today and spoke yesterday. Local Works and Bureau Happold, who wrote significant parts of the materials and construction section, and who are also both present today. Engineer Paul Kimira, who has worked with the Fielden Foundation for many years, and he gave his experience to the Environment and Services section. And local and international architectural practices, who have allowed us to share their work through their case studies, and they'll be talking more about those in just half an hour. And I guess another very important part of our consultation was testing the principles that we developed with designers who had perhaps the most recent experience of being at school. So we were very glad to run a 2-day workshop with final year students from the University of Rwanda, facilitated by Alex, who have focused on educational buildings for their final year project. And it is wonderful to have them here today, learning but also giving and sharing their experiences and their insights. So do take a look at their work. That is around the back of the room if you haven't done yet. So what were some of the things that we found from visiting all of these 40 schools? Well, this is a picture from, as it happens, the first school that I visited. It's just over the border into Uganda from Rwanda on the edge of Lake Mutanda, called St. Peter's Pre and Primary School. It's in a very remote area. It's not a government school, but is run and funded by the community. And it's single stream from kindergarten up to P7. It's in a beautiful location, but to be honest, has fairly unpromising facilities. Poor quality bricks, patchy shutters, no electricity or running water, earth floors still with rubble in the background. It's about 40 meters down to the lake, which is the water source, and water collected by the students goes into this container where they can wash their hands. The toilets you can see in the background are really just a shack with some rudimentary curtains around them. In infrastructure terms, this school was one of the most extreme I saw, and lots of schools have much better infrastructure than that. But I think one of the things that stood out to me was not necessarily just the infrastructure, but an interaction I had with the class. This was during the holidays, so they had a kind of summer school. It was a slightly smaller class, but we were shown around by a very enthusiastic and kind head teacher called Mr. Africano. And when I went into the classroom, he was introducing me to the students and said, "So what is it you do?" My husband is a doctor. He'd already said that, and they were very excited. So I said, "Oh, I'm an architect." And they were all blank faces. I said, I do architecture? Mr. Africano was not sure. So I said, I design buildings? And suddenly his face lit up. He said, She is a designer. Now, she is not a builder. She does not build the buildings. She does the decoration. I know there are lots of architects here in the room, and I don't know how you feel about that being the primary definition of your profession. So anyway, it's an interesting anecdote, but what it really made me think about was, how is this school's design guide that I'm trying to research going to impact people in a school where the head teacher only got as far as S4, and even he doesn't know things that we would consider fairly standard knowledge. But it's not just schools like this that we wanted to focus on. I also visited schools like this. It's a really very well-resourced boarding school in the north of Uganda with a phenomenal sports field. I mean, you can't imagine being able to sit in an arena like this. But this is their kitchen, and this is probably not a surprising sight to most of us here. But if you can imagine the walls of the kitchen look like this, what do the lungs of the people working there look like? And not only that, but what about the carbon emissions from very inefficient wood-burning stoves that are used to cook posho and beans and are basically burning all day long? So we hope that the guide has something for both of these kinds of schools, even though they're very different and their contexts are very different. We're aiming to balance these different challenges by offering designs that are achievable on a restricted budget, which can be built without high technical expertise by local people, and which will improve the quality through master planning, landscape, and internal comfort. And we won't produce every school like this from day one, but we hope that we will move everyone one step up the ladder. We also are looking to the future, thinking about what will be required in the next 10, 30, 50 years in terms of facilities, spaces, technology, and mitigating for climate change. And I was in the innovations and integrating technology into classroom seminar just before coffee, and it was very interesting and particularly inspiring to see what Rwanda is doing in running out a very systematic and thought-through program of digital transformation. This image here is from one of the students, one of the designers of the schools of the future. Halfway through the fieldwork period, the opportunity arose to design a vocational school for the charity Ignite Change, who are based in Kamdini, and this was in collaboration with EMI Uganda, who we'll hear from later. Due to time and budget constraints, the aim was to apply these evolving principles of the school's design guide to the project in a light touch way that could be handed over to a technical engineer or site manager. So just to take you through the design in terms of the headings of the book, to give you a flavor of what we've included. To set the context, Ignite Change supports vulnerable people through skills training, community work, business support, and advocacy. And so our brief was to design a 3-phase vocational school that would sit on the Gulu-Kampala highway and include business outlets to ensure financial sustainability. Because of the phasing, understanding the future needs was really important, and we knew that they would evolve as time went on. So in order to not do work that would be later aborted, we were quite careful to, for the latter phases, really just apportion areas of the site and not pretend that we knew exactly what needs they would have in 5 years' time. The buildings were designed using the principles of bioclimatic design, with enough flexibility that they could be adapted to different uses as the school grew. So this is just an example of the basic classroom that could also be used as a dormitory. Landscape was a very important part of the design, especially as the front of the site, which, if you can see my cursor is here, that had previously been partially excavated during the construction of the highway, so was a haven of biodiversity from our point of view. Some from the client also felt it might be a snake pit. But we've encouraged them, and they're really excited as well, to develop that into a botanical garden that will then become part of the business attraction of the site. ISSB, so interlocking soil stabilized bricks, which are demonstrated here, was chosen for the main walling material for its relatively low cost, low carbon, and durable nature that doesn't require plastering, so it reduces long-term maintenance costs. Our interdisciplinary team of 4 included a civil engineer who was able to carry out soil and attenuation tests while we were there on the site in those 4 days, meaning that we could plan all of the infrastructure from the outset. So we completed the designs last June, and the client moved astonishingly quickly to start building, appointing a local engineer to do the technical and permit drawings, and then to manage the project on site. And to my astonishment, a couple of months ago, the school opened for its first term. I'm delighted to say that Okello Ambrose is here today. Maybe you can wave your hand. He's there, thank you. And he is one of the school leaders, and so do ask him afterwards about the construction period and how it's been for them. As with any project of this size, there were many lessons learned, and just 3 of those to share with you today. Firstly, that it is possible to design a vocational school in 4 days with full engagement of the design team, the client, the site, and a real prioritization of time. Secondly, that planning for expansion and phasing is really important, and that as an architect, certainly in this context, that meant letting go of the detail. It meant accepting actually a much smaller role as part of a bigger team in the long term. And I guess I'd suggest that in a country like Uganda, where we know there are very few architects compared to the rate of urbanization, this is probably something we might have to get used to, that many architects will have a role at the master planning stage, and then maybe at the detailed design stage, some of that could be handed over to technicians. And finally, and I think most importantly, it's that when your client is motivated and organized, they can get things built an awful lot faster than we could ever dream of in the UK. And so huge credit to Ignite Change, who were in many ways the ideal clients and a complete inspiration to me. So what next? Well, we're delighted to launch the School's Design Guide today in its draft form. I'm going to wave a little copy of it here. We really look forward to incorporating insights from the speakers and attendees of this conference into the finished version. And as been said, the people in this room and the expertise and experience included is amazing and not to be taken for granted. The next message, I guess, is of adaptation. So we think that this guide and the principles included should pretty well be applicable to most or a lot of East Africa. But we also recognize that East Africa is a very big place, and it covers different climates, different socio-political contexts, governments, and cultures. So while we have written down the basic principles, there will be a need for each country to write its own, perhaps introduction, setting the scene, but also an addendum looking at national design codes. We're going to do that for Uganda, which will hopefully set an example. But if you are from one of the other East African countries and you're thinking, this is something we want, then please come and talk to us, because we want to help facilitate that, but we also recognize we are not the best placed to access and bring in all of the national design codes from other countries. So as I close, one thing is certain, and that there is no one-size-fits-all design. We have tried to show principles that we think will work, and that includes some example classrooms and cross-sections. But we can't pretend that the same school design will work in Kampala as will work in rural Burundi. And in an imperfect world of constraints, there will be no perfect solution, only pragmatic compromise. But humans thrive in complexity, and we grow together through collaboration. We learn from each other's mistakes. Architects are not only designers and decorators, but we're problem solvers. And together with all the professionals and stakeholders in this room, we have the ability to shape the classrooms of tomorrow for the better. The next question I think you will ask is, where can I get a copy of this guide? Well, the good news is you all have access to it from where you're seated right now. So if you scan the QR code on your badge now or later, and then go to the website that it takes you to. There is a link where you can download the draft design guide. The next QR code is for a feedback form, and we really do value your feedback, and we will take all of it into consideration. You can scan the QR code now, or if not, it will be shared by Meryl. So we would love you to fill this in and let us know what you think. There might be things that have been omitted, there might be things you think are mistakes, or you might just say, actually, yeah, this is really useful and I wish I'd known this 10 years ago. Either way, yeah, we look forward to that. And so I'm now drawing to a close, but I just wanted to invite Felix up. He's been working with us on this guide since the beginning, and is just going to give us a bit of an opinion from the architect working in Uganda's point of view as to how this might be used.
Thank you. Yeah, I'm not going to take up much of everybody's time here, but the first point I would like to make is that Peter and Meg have been very modest in describing their own role in this. They are really the authors of this wonderful book, and those of you who will have the chance to read it will see that this is really an incredibly comprehensive compendium that anybody designing schools in East Africa will find very useful. So I want to first of all congratulate Peter and Meg for this unbelievable amount of work they have done. And in a way, you know, as a practitioner who will make active use of it, just simply thank you for doing this. Who is going to benefit from this book? Who is going to be able to use it? I can think of three primary sort of user groups. The first one will be designers and those who want to become designers. So this book is specifically for architects and engineers and students of architecture and engineering and landscape design for that matter. I can only hope that all regional universities will make this book part, a very active part of their curriculum. This is a real teaching tool. Meg asked me yesterday whether we should ask people, you know, what is missing in that book, and I told her there's nothing missing in that book. It's all in there. Really, any kind of consideration that I can think of that you need to put in place, you'll find it there somewhere. So I hope all those teachers and students who are here will embrace it and will start using it on a daily basis. The second group that I think will find this book very helpful is the private sector, school owners and school developers. The association that Mike is heading up, I believe there's many other of those associations. I hope you will find a way of distribute this handbook to all your members, and I think that maybe not everything, but a good amount of information that is in that book is also of a great benefit to less technical people. There's a lot of practical, hands-on, diagrammatic advisory in there. And then last but not least, I do hope that the Ministry of Education, CMU, all technical members will also adopt this book. There is so much useful information in there that could inform and could really revolutionize the standard design of the ministry. I can certainly say that everybody who is involved in that book is open and is available to assist in improving our standard designs, and I feel this book will play a great role. Last but not least, that is my last sentence, I want to thank Enabel. The team of Enabel has done an amazing job and has played an amazing role in supporting all of us green designers and builders in the region. This is going back quite some time, but it certainly goes back to the first conference on climate smart design, which was held in Kabira, not far from here, maybe in 2018 or something. So about 5 years. Matthias was the lead at that time. and now Frank has taken over, and I really, on behalf of all my colleagues, I want to thank you for your unwavering support of green design, and I'm counting on you as we are not yet done. Thank you very much.
No, I honestly, so I thought Meg would wrap up and just, throw it back, but thank you so much, Meg. Can we once again appreciate Professor Clegg, Meg, and Holland? Well, you did a good job in summarizing this into 17 minutes. If there is any questions, don't worry, we are going to put them up in the Woo Club, all right? So if you have any quick questions, not necessarily about the design, because you haven't even looked at the draft, so you can't ask any question. First look at it. They've told you where it is, so check, download it, look at it. And if Holland is to be the example of the critiques of the design or the guide, clearly he says there's nothing missing. And so you're only going to find a reason to just say something about the design. But honestly, once again, can we appreciate the entire team for putting together the draft? And also, in a very special way, I did introduce the fact that we will have VIPs joining us this afternoon. I want to, in a very special way, and I will at an opportune time, of course, welcome him, but we want to receive the ambassador. Your Excellency, you're most welcome. Thank you very much for joining us. All right, so let's do this very quickly now that you know the VIPs are here. So allow me move to our case studies. Yes. I was going to skip this part, don't worry. So we have, and I had introduced the commissioner, of course, and we want to appreciate the Ministry of Education and, of course, Enabel that has gathered us here these last 2 days. As my other commissioner, Asaf, also joins us, engineer. Thank you so much for joining us. So we will move into the formalities, and Meg, I know you are trying to organize there, so that, will we need a stand, David? Will it be possible? All right. So ladies and gentlemen, I want to take the singular honor and pleasure of inviting His Excellency the Ambassador of the Kingdom of Belgium, Mr. Hughes Chantry, to come and address this group of delegates. Can we welcome him? Meg, can you ensure the mic is on, Meg? It is on, Meg? Thank you so much. You're welcome, Your Excellency.
Well, ladies and gentlemen, good afternoon, and thank you for having me. Actually, when the colleagues of Enabel invited me to address you today, there is something they didn't know. My father was a civil engineer, and he has been actually in the process of buildings, quite a few buildings in Belgium, and also roads and so on. Then I feel a little bit home here with architects and specialists. Well, first of all, I would like to thank you all for attending this conference. And while actually walking to the room, the colleagues of Enabel told me that during the course of your sessions and work groups and so on, the participation has been very active, and there have been many insightful contributions, and it is quite clear that your commitment actually for the advancement of sustainable infrastructure in schools in East Africa, this commitment is definitely unwavering, and for that, thank you. I know also that during the past 2 days, well, I should say 1.5 days, you have explored innovative ideas, engaged in thought-provoking discussions, at least that is what I hope, and forge new partnerships that will drive our collective mission forward. And the diversity of perspectives and expertise shared here will be definitely, I'm sure, a source of inspiration, as it appears that we all share common vision for a resilient and sustainable future. Ladies and gentlemen, despite the advancements in educational practices and technology, many of the school designs remain out of step with evolving curriculum and climate models. And I'm sure this conference provides an opportunity for us to rethink and reimagine how we design and build schools. And we must focus on creating spaces that are safe, inclusive, and adaptable to the evolving needs of the learners. The draft school design guide represents a significant milestone in our collective efforts to achieve this, not just here in Uganda, but across the whole of East Africa. And I would even say, of course, I know this conference is dedicated to East Africa, but we could say the whole of Africa. And it shares our experiences with innovations, participation processes, and resource utilization to inform best practices that we can carry with us into the future. Just like the current conference, the guide brings together the expertise of key stakeholders and actors, such as architects, designers, educationalists, teachers, and of course, students, to inform our school designs. Our vision is to create a future where every school is a model of sustainability, inclusivity, and excellence. By working together and leveraging our collective expertise, we can transform our educational landscapes and ensure that every child has access to a high-quality learning environment. Ladies and gentlemen, Belgium, well, it's time I speak about Belgium. After all, I'm the ambassador. Belgium, through Enabel, has been a steadfast partner in supporting educational development in our partner countries in East Africa. And our commitment to promoting sustainable and inclusive education is unwavering. In recent years, we have supported the education sector by enhancing infrastructure and teaching methods in national teachers' colleges and vocational training institutions. And this has ensured better access to education facilities and equipment to support teaching and learning for the youth. And today, of course, it is our intention to use the knowledge we have gained here to inform the infrastructure developments within our projects, especially in the We Learn, We Teach projects across Busoga, West Nile, and the Albertine Rwenzori regions in Uganda. And I hope that as we leave this conference, we can each carry forward the knowledge and connections we have gained. I hope there has been a lot of networking, and transform them into actionable strategies and projects that will benefit our communities. And remember, the discussions you have had here are just a beginning, and it is up to us, well, mostly you, to implement these ideas and make a tangible impact. I'm sure that together we have the power to shape the future of our region's infrastructure, making it more sustainable, resilient, and inclusive for the generations to come. Well, I wish you, of course, a safe travel. It's a little bit too early because once my speech has been written, it was not yet sure when I would speak. Then I think that your work will go on this afternoon, but I already wish you, for those of you who came from outside Uganda, I wish you a safe travel. And of course, I thank you all for your participation. And I hope in the near future here in Uganda to have the possibility to see brand new infrastructures made by Enabel and inspired by your work today. I thank you very much indeed.
Thank you very much, Your Excellency, and thank you for finding time to join us. And apologies, we're talking about design, but the height, we've talked about this, we've talked about it. So, all right, okay. I'm glad you found the soft side of it. It's a good exercise. We were complaining that it's only meant for the tall people, only, a couple of us, me and Meg here. No, I wasn't saying that indirectly. I wasn't saying that. And I'm glad you said it. Okay. Your Excellency, it's been, like you said, it's been quite exciting listening to, especially to the architect students, or students of architecture. I think that's the better way to say it. And that's the majority of the group here. But I also discovered you're not alone. I and a few others felt very left out. We are not architects, we're not landscapers, we're not engineers. And so we've learned quite a bit of their jargon over the last few days. And so when we walk away from here, we're going to speak with quite a bit of expertise, myself, William and others. And we are going to sound like we know what we're talking about clearly, and yet we don't. But it's been really exciting to be here. But that said, I'll invite Engineer Asaf. You're only going to do one job, Asaf, when you take the mic, is to invite the commissioner to address us. I'm playing politics, so Engineer, please come. Engineer Asaf, for those of you who don't know, is our Assistant Commissioner in charge of the Construction Management Unit at the Ministry of Education and Sports. So Engineer, the mic is there. Yours is to, don't say anything else. Invite the Commissioner to address us.
Your Excellency, the Ambassador of Belgium, invited guests, ladies and gentlemen, my job is one. I've been given strict instructions to invite the Commissioner to speak with us. Commissioner Juliet Muzora Atairwe is the Commissioner for Government Secondary Education. Madam Commissioner, I have the honor to invite you to speak to us.
Thank you, Engineer Asaf, for the kind invitation and introduction.
Your Excellency, the invited guests from the diaspora, Enabel team, my colleagues from the Ministry of Education and Sports. Engineer Asaf has introduced me, so I would like to go straight to the brief remarks that I have for this gathering. I bring you greetings from the Ministry of Education and Sports. It's my honor to again welcome you all to this significant event, the Sustainable School Design Conference for East Africa. I extend my heartfelt thanks and great appreciation to Enabel in Uganda, to the Ministry of Education and Sports, and to all the organizers for making this important gathering possible. We are gathered here, ladies and gentlemen, with a shared vision to shape the future of educational infrastructure in East Africa. This conference is mainly to discuss ideas about building a community of practice that will drive innovation and sustainability in our school designs. Today, we are here to officially introduce the draft school design guideline. This document represents the collective efforts of over 30 experts and the insights gained from studying 40 schools. It is a comprehensive guide aimed at promoting the creation of schools that are community-centered, climate resilient, energy efficient, cost-effective, and durable for posterity. The core objectives of the guideline are mainly four. One, community-centered, that it should be a community-centered design, emphasizing the role of schools as integral parts of the community, fostering engagement and ownership. Two, that it should have climate adaptation, ensuring that our school designs are responsive to the local climate, promoting sustainability and resilience. I think you heard that from the architect when she shared with us the samples and the contextual characteristics of the different schools that she visited. Three, that it should be cost-effective in energy, striving for designs that minimize energy consumption and maintenance costs, making education more affordable and accessible. Four, there is consideration for inclusivity and accessibility, that these designs should cater to the needs of all students, including those with special needs, to ensure that every child has access to quality education. We encourage participation and feedback. The introduction of this draft guideline is just the beginning, like you heard the previous speakers say. We seek your active participation, insights, and feedback to refine and enhance this document. Your input, ladies, gentlemen, architects, designers, and students, and engineers, your input is invaluable in making this guideline a robust tool that meets the diverse needs of our region. I urge all stakeholders, the architects, the engineers, the educationalists, the designers, the consultants, the policymakers, the academia, our development partners, the students and the community members to engage fully in this session. Your contribution as stakeholders will help us create schools that not only educate, but also inspire and sustain, are sustainable for posterity. The vision is to have every school in East Africa embody the principles of sustainability, inclusivity, excellence in education. This guideline, ladies and gentlemen, is a step towards achieving that vision, and your involvement is crucial. In conclusion, I would like to thank all of you for your commitment and dedication to improving our educational infrastructure. Let us work together to ensure that schools that we design today will stand as beacons of hope and progress for generations to come. With great pleasure, ladies and gentlemen, I would like to ask you, Frank, for guidance, because I'm introducing the school design and wanted to request His Excellency to join, because I would like to request him to introduce it. So kindly guide me on the next step.
I have deployed Frank to brief you.
Thank you. With that guidance, ladies and gentlemen, and with profound pleasure, I officially introduce the draft school design guideline for your review and input. I say all this in the spirit of development for God and my country.
All right, so I'll request the commissioner and the ambassador to make their way as Frank guides on the other consultants and stakeholders who are going to witness this unveiling of the draft school design. The commissioner and ambassador will append their signature as in a way to, first of all, commemorate the fact that we now have a draft in place. Then the draft, as mentioned, will go through the necessary processes that include, of course, the ministry taking this to all the stakeholders for it to be approved. So I will request His Excellency the Ambassador, so you can unveil and be able to allow them. His Excellency the Ambassador and our Commissioner to be the witnesses of this very first draft, the single draft of our school design. There you go. And then they will formally append their signatures to this. Can we give this a round of applause, ladies and gentlemen? All right, so I'll ask Frank to give the ambassador and the commissioner the pen, the markers. Yes, engineer, can you give a commissioner and ambassador? Each will sign. Please pick a nice place as long as it doesn't affect the literature on the design. Feel free, Commissioner, go ahead. Yes, and I discovered it's one of your colors in the flag. So clearly that's your color. No political significance, Ambassador. Thank you very much, Commissioner. All right. Yes. Thank you very much, Ambassador, Your Excellency. Okay. I'll invite Professor Meg to come closer as we take this photo. And the Ambassador will formally hand over the design to the Ministry. Prof, come on this side. Professor, if you can come on this other side. And Meg, yes. Frank, good. Ambassador, go ahead. Hand over the draft to the Minister of Education. Round of applause, ladies and gentlemen. This is formally to ask the Minister of Education to then start the work to have this draft into policy and, of course, to guide the way forward for our infrastructure. I'll request, I don't know, Frank, do you want more photos? I am happy to allow you guys to have more photos here so that without, there you go. Cameraman, I'll give you a minute. Yes. And then I will immediately dive into our next stage, which is the very final stage before lunch, where we will have some case studies, all right? Thank you very much, Your Excellency and Commissioner. Please take your seats. Another round of applause, ladies and gentlemen. Our very first presenter for this session, and I want to quickly invite the technical team to put our first video presentation. It's a case study of schools, and these are the different speakers that will be speaking to this. We are starting with the ASA studio. Alice Tasker, Principal, Umubano School Extension. It's a video presentation, so I'll invite our technical team to play that.
Good afternoon, and thank you for inviting us to this conference. Today we present a case study, the Umubano Academy Extension, Analysis and Lesson Learned of a Connecting Project. ASA, short for Active Social Architecture, is a Kigali-based architecture and engineering practice founded in 2012. ASA believes in addressing every project through a thorough study of its context. This involves researching the community where the project is located, exploring locally available materials and construction techniques, and developing design strategies that consider all aspects of the project. Our approach includes collaboration with a wide range of professionals and stakeholders to ensure the design process extends beyond the building itself. Although the Umubano Academy Extension was completed in 2008, Analysis and lesson learned of a connecting project. ASA, architecture and engineering practice founded in 2012. ASA believes in addressing every project through a thorough study of its context. This involves researching the community where the project is located, exploring locally available materials and construction techniques, and developing design strategies that consider all aspects of the project. Our approach includes collaboration with a wide range of professionals and stakeholders to ensure the design process extends beyond the building itself. Although the Umubano Academy Extension was completed in 2018, we chose it as a case study because its design process and the lesson learned remain highly relevant today. The project involved adding a 650 square meter extension to an existing primary school, which included a new classroom block for secondary students and a Good afternoon, and thank you for inviting us to this conference. Today we present a case study, the Umubano Academy Extension, Analysis and Lesson Learned of a Connecting Project. ASA, short for Active Social Architecture, is a Kigali-based architecture and engineering practice founded in 2012. ASA believes in addressing every project through a thorough study of its context. This involves researching the community where the project is located, exploring locally available materials and construction techniques, and developing design strategies that consider all aspects of the project. Our approach includes collaboration with a wide range of professionals and stakeholders to ensure the design process extends beyond the building itself. Although the Umubano Academy extension was completed in 2018, we chose it as a case study because its design process and the lesson learned remain highly relevant today. The project involved adding a 650 square meter extension to an existing primary school, which included a new classroom block for secondary students and a multipurpose hall. The client, APIE, is a UK-based NGO that has been operating in Rwanda since 2009. The academy is located in Kanombe, Kigali. During the design phase, ASA identified two main elements that characterize the project's context. The first element was the presence of the existing primary school. Designed in 2011 by Mass Design Group, the 900 square meter school includes 9 primary classrooms, a library, and integrated outdoor learning spaces. The second element was the dense and rapidly changing urban fabric and wetlands surrounding the school. Between 2004 and 2017, when we began the design, the neighborhood experienced rapid growth, and an informal settlement emerged along the northwest plot boundary. A more formal settlement became denser along the north and eastern boundaries, with informal pathways connecting the hilltop to the valley, where a wetland is located. About 63% of Kigali's settlements are unplanned, characterized by limited access to basic infrastructure and poor living conditions. Kigali's urban wetlands cover about 10% of the city and play a significant role in the national economy. Wetlands are used for agriculture production, act as hydrological regulators, serve as biodiversity reservoirs, and hold great cultural value. As a result of these contextual considerations, ASA developed a connecting project. The project, in fact, conceptually connects inwards to the existing facility and outwards to the formal settlement, the wetland, and especially the unserved community of the informal settlement. The concept design focuses on connecting visually, physically, and programmatically to the existing primary school on one side and the community on the other. The plot was initially occupied by 2 illegally built pit latrines used by the community and 15 houses informally built along the plot edge. The informal settlement lacked clean running water, had footpaths and soil highly prone to erosion during the rainy season, and the community relied on the wetland for agriculture, water, and foot access to the other hill. Despite these challenges, ASA persuaded the client to consider a design that would improve the situation of the informal settlement. This approach embraced a more inclusive strategy to positively impact the school's safety and gradually enhance the living condition of the neighbors. We wanted our project to go beyond the physical limits of the plot. The inward connection refers to how we connected to the existing school. This involves studying the materials, construction systems, and daylighting to integrate similar aspects into our new facility. We also gathered feedback from the client on areas they wanted to improve, such as stormwater management and classroom waterproofing. Workshops with parents, teachers, and students were conducted to involve them in the design process, and we engaged the community during the construction phase. Practically, connecting inward meant designing a connecting edge with the primary school. ASA developed a circulation system that included wheelchair ramps, landscaped areas, drainage channels, outdoor learning spaces, age-specific areas, and a new office. This connecting strip serves as both the physical and programmatic link to the existing primary school. Here are some images that showcase the connecting area to the primary school. The outward connection refers to how we connected to the neighbor and the wetland. This connection involved positively impacting the community through the improved education provided by Umubano Academy and including the community in the design process. Local authorities and stakeholders participated in the participatory design, and we learned from the residents of the informal settlements about their main challenges, such as the lack of toilets and clean water, inadequate lighting along the footpath at night, and the presence of snakes. Consider this, we designed the connecting strip to the community to include a paved staircase lit at night by solar lamps, a new drainage system, small sitting areas for community gatherings, community laundry and toilet, and a water kiosk with rainwater collected from the roof of the new hall and filtered. Access to the school and hall, which can be rented by the community for event, was also opened along the northwest fence to facilitate access for neighborhood children. The connection and access to the wetland were also designed and improved to provide parking space for the school and enhance flood control. The site plan clarifies how the connecting strips work, with the inward edge connecting and serving the school, the outward edge serving the community and enhancing the connection of the hilltop to the wetland. The interior distribution of the facilities is clear in the floor plan, with the new classrooms block at the top of the plot, accessible from the primary school while being located in a more private and age-dedicated space. The classrooms, which offer inbuilt teaching equipment, have double access to ensure wheelchair accessibility from the back ramp and fast evacuation. An ample outdoor learning space is located along the front facade and connected to the inward connecting strip. The new teacher's office is integrated with the hall and the circulation, acting as programmatic link between the existing school and the new facilities. The hall is designed to host 400 people and accommodate multiple activities, from dining space to an auditorium and wedding hall. Accessible from all sides, the sitting space leverages the natural slope of the ground to create bleachers and a stage at the lower level. A block of services, including toilets, kitchen and storage, is located along the northwest facade, where it acts as a shield from direct heat gain and ensures optimal interior comfort in the hall. Natural cross-ventilation, diffuse daylight and shading systems are also implemented in the hall to improve interior comfort. A 21-meter-long skylights provide plenty of indirect sunlight during the day, minimizing the need for artificial lighting. Blinding curtains can be used to regulate the light for projections. Small openings characterize the west and most exposed facade to minimize direct heat gain. The other three facades of the hall are glazed and designed with doors, opening ventilation panels, screens and shading devices arranged in layers according to the facade exposure to regulate interior temperatures and comfort. Despite the size of the hall and the 21-meter span of its roof, ASA implemented the construction using low-tech and locally available materials. The local community supplied the site with workforce, and the construction costs were minimized. Our original design included two additional parts that addressed the challenges of the community beyond the school physical limits. The first was the improved accessibility system to the school through the wetland. The second part was the serviced circulation along the northwest plot boundary, which included communal services for the informal settlement. Despite these proposals being relatively inexpensive for the NGO, they ultimately decided not to fund these additional elements. This decision, while understandable from a budgeting perspective, represents a missed opportunity for a broader positive impact on the community. The inclusion of these amenities would have significantly enhanced the quality of life for the neighborhood, addressing essential needs beyond education. While ASA still considers the design process quite successful from a conceptual standpoint, there is quite a lot to learn from the project's outcomes. This lesson learned is relevant as we move forward into other projects because it defines how we see our role as architects within the project ecosystem. As architects, we play a significant but still limited role, where other players need to coordinate for the project's success. While every architect can decide to play their role differently, often defined by the nature of the project, ASA believes in design to build social capital through community empowerment. However, throughout the process, we must keep in mind what community empowerment entails, as it implies an exchange of power. Some power is ceded and some power is acquired. While the community gains power, the architect and other stakeholders naturally lose some. It is within this unbalanced distribution of power that we found the main challenges to this project's full success. Firstly, the role of the outside agent, in this case the client, who, despite the initial enthusiasm, decided the implementation of the outward connection was not economically justified. Secondly, the lack of policies that would support or incentivize the developer to include community beneficial interventions beyond the school grounds. But, as architects playing a role in the project's ecosystem, if we want to design and reach beyond the physical and programmatic levels of the classroom space, what can we do? How can we encourage private developers to invest more in projects that can benefit both their activity and the community where they are located? And how can architects collaborate more effectively with policymakers to ensure private investors are more inclined, supported, or incentivized to include community beneficial interventions in their projects? We hope our insights and questions will trigger an open debate among experts seeking to advocate for holistic education facilities. Some initial ideas could include incentive programs, public-private partnerships, policy advocacy. What else? By addressing these areas, we can strive to ensure that future projects not only fulfill their primary educational objectives, but also contribute to the sustainable development of the communities they touch. Thank you.
All right, that was well put together, because that was Alice Tasker, who was the principal architect on this project. And we'll now dive into the next presentation from Mass Design by Alain Nwali. If you're not from Rwanda, you'd probably call him Twali, but he's Nwali. Martin, who of course we were with this morning, it's a joint presentation. The both of you have exactly 10 minutes starting now.
Thank you. I will not say much. Just to introduce Alain. Alain is a graduate from the University of Rwanda in the School of Architecture. He is currently working with us at Mass Design Studio, which we introduced this morning as our intern helping us under the learning and entrepreneurship focus area. And he will be giving a presentation on one of our very early on projects. It's a school design, and I will let him talk about it.
Thank you very much. As mentioned, my name is Alain Nwali. I'm an intern at Mass Design Group. Today, I'm going to talk about one of the schools that Mass did in terms of extension and rehabilitation of schools. So I think Martin has already introduced Mass Design, so we don't need to go into that. So the school I'm going to talk about is Mubuga. Is Mubuga Primary School located in Musanze district. So the first question I'd like to ask, or everyone ask himself, is can school design improve the quality of education in general? For example, if you look at the school itself and the built environment. So in terms of what Mass did with Mubuga Primary School, it was an extension.
Hi, I'm Miko Kobayashi from Terrain Architects. First of all, I would like to express my gratitude for this opportunity. Unfortunately, I'm now in Tokyo, so please.
The other thing is non-responsive design, where you have classrooms that do not respond to the climate and the context itself. And the third is lack of play space, because usually what we have seen in many schools is that play space are built as afterthought. That means you need the classroom first, which is true, but then there are other facilities and activities which support the classroom itself. The other thing is how the school itself connects with the community. That means, as there's a popular proverb, African proverb, which say, "A kid is led by a village." That means, which is true. That means, can we integrate the community itself within the school itself? So, in the design interventions that Mass did, the first thing is to rethink how the classroom itself is designed in terms of how they respond to the climate and how the classrooms enhance the learning activities for the kids. And the second thing is play spaces. how does play spaces affect the kids' mood, for example, and the experience at school. And the third is how the classroom, how the school itself facility is integrated into the community. Is it useful? For example, as we know, that means, for example, in holidays or in the weekends, can the school itself be useful for the community? And the fourth is how the construction of the school itself help the community in terms of operation and construction process. So if you look at, for example, if you compare the two, the mass classroom and the existing classrooms, which are usually everywhere by UNICEF, the UNICEF classrooms resolve the issue of having a classroom itself, but it doesn't address the context and the climate issues associated with the building itself. For example, shading, where the light's coming from, enough lighting, acoustic problems. So that's what MAS did, was to rethink how the classroom itself can be made better using artificial interventions. So the first thing they did is improving the lighting by providing clear stories and narrow windows to minimize the glare inside the classrooms. And the other thing is using ceiling materials that itself absorbs sound, so that there's no, for example, when it's raining or when there's noise in the classrooms, that means the noise is still low in that sense. So if you look at what MAS did, is to provide the black classrooms, which affect how kids themselves feel about the classrooms and how they are used. And the other thing that is usually looked or not looked at is the furniture themselves. As you know, kids from primary 1 and primary 6, they have different economics. That means they have different needs in terms of how do they feel about the classrooms. If someone is sitting in the chair, they're supposed to be for primary 6 students. It's very hard for them to learn and spend time in the classrooms comfortably. So one approach is to provide modular chairs. That means where you have a desk and a bench, they are different. That means they can be arranged accordingly. For example, if they have more group work, that means they affect how the classroom itself is set up. That means they have fewer kids per chair because the classrooms are bigger in that sense, and they are adapted to, and they are also appropriate for their size in terms of, so that means they have to stand while writing, and in that sense. So, as most of you have already mentioned, the classroom is not just about only 4 class walls. That means there's other way aspect of classrooms, is that, so in this instance, what MAS did is to provide an outdoor classroom, which can be used by community, for example, if there's a meeting for cooperatives, and also by students when they're learning complex subjects, for example, in the afternoon, because usually there's very hot and everybody is very sleepy. That means if you have outdoor classrooms, it can be beneficial for the kids to learn outside rather than in the inside of the classrooms. So that means that being another aspect of the school is the play space. Usually kids prefer to play more than to study. That means because that's why they interact with their peers to improve their social skills and everything. That means the aspect of playgrounds is very crucial for the kids, especially for younger kids, and in that sense. So to provide more diverse play space for the kids, at the same time also be eco-friendly and think about the impact of the construction itself. For the Muga Primary School, what we did was to use only excess materials that left over from construction, and to provide very diverse play areas which are unconventional. That means they don't have any rule. Kids can play wherever they want. They can set up their own role in that sense. And as I mentioned earlier, the school itself does not sit in the isolation from the community itself. That means it's very intertwined with where it's located. So how does, for example, the construction of school include the community itself? Where does the material come from? Who's building it, and everything? And one approach is using low fab, which I'm very aware that most of you are very familiar with, is using technology which is available on site. For example, if you're building school in rural areas, it can be beneficial to use local materials, which can benefit the community themselves in terms of economic gains and employment, and also who is building a school. Is it women or men? So because mostly in construction there's only men in construction, so if you include the women, that means the process of building school is more diverse in that sense. And another aspect of looking at community engagement with the school itself is the spaces within the school. For example, for Mubuga Primary School, there is a pavilion which can be used by communities, for example, cooperative meetings, local meetings, and everything, which is very beneficial to the school. Sometimes they're also wedding photographies at school. That means they pay in an economic sense. That means they get money from the landscape they have, which is by both students and the community outside the school. So, to recap, the impact that the project made in terms of it did affect both students and the community around the school in terms of where kids have better learning spaces and play spaces, and also for community they get from it because there is economic incentive in terms of if they have job or the materials that you use is from the local markets and everything. That means they also have incentive to love the school itself. That means they are more engaged and they care about the school itself because it's benefited them, not only students and teachers. Thank you very much for the presentation.
All right. Just as they prepare the next, because our next presentation is on video, right? Just to make sure. Is there in the course units a presentation on public speaking? Because we need to probably get that one for architects also, Professor. A lot of the time you're going to have to interface with crowds to be able to explain your design. And so maybe we need to include that. And that I can teach, public speaking. I'm joking. I'm just finding myself my next job. All right. So we'll move to Iko Kobayashi from Terrain Architects. The presentation is on Terakoya School. It's a video presentation. So there you go. We'll just ensure that the sound is okay. All right.
Hi, I'm Miko Kobayashi from Terrain Architects. First of all, I would like to express my gratitude for this opportunity. Unfortunately, I'm now in Tokyo, so please excuse me for presenting through video today. I would like to introduce a project called Terakoya as a case study of the school design project.
Before starting, I would like to briefly introduce our team. Together with Fumika Shimura, I set up the office in 2011, and we are currently based in Tokyo and Kampala. We've been involved in about 3 architecture projects in Uganda so far, and are currently working on projects in both Uganda and Japan. The project I will introduce today, Terakoya School project, was done in collaboration with Plantech Limited from Uganda. First, I would like to talk about the location of the site. It is in Nansana, which, as you may know, is about 10 kilometers north of Kampala. It was a village when I first visited the site around 2003, but is now a busy suburban municipality. This is a site location plan, including the neighborhood. The site is located down east from Koima Road. The gray area in the bottom right is the client's head office, built in 2002. The site for this project is located opposite to this, on a rectangular sloping site. The client of this project was Ashinaga Uganda, an NGO which has been working in the region since 2001. They have been steadily providing psychosocial support to children who have lost parents, and one of their main activity is the Terakoya program, which is an informal educational program. This is an older picture which shows a non-formal school at the local temple in Japan during the Edo period around the 17th century called Terakoya. The Terakoya program for Ashinaga, Uganda is based on an informal learning space like this. A space where teachers teach students of different ages with different level of the proficiency, and students also teach each other. This historical but mature educational program is often referenced when rethinking what a modern school can be like. This is a picture of the site before construction. The project was initiated in 2017 when the opposite land for the head office of Ashinaga, Uganda was acquired. The Terakoya program was initially only using a part of the head office building, but the construction of the new building, which can also function as a community center, was taken into account due to the increases in the number of students as well as the need for vocational training and support for parents. A major decision taken by Ashinaga, Uganda was to make a new Terakoya as an informal school with a program from primary 1 to primary 5 and transfer students from primary 6 to other local schools. This decision was taken after many consultations to ensure that the school would not only function as a school for the pupils, but would also be open to the community. The fluid nature of this Terakoya program was essential when considering how the new architecture could be. It needed to be a place that could accept a variety of events throughout the year's schedule, from routine classes held in small groups, to meetings outside of class, to morning assemblies for the whole school, to events held in large groups. For this reason, instead of putting up a large site-filling building, we chose to design a collection of smaller units composing the architecture. This complex program was nothing new to the area, but had been taking place both inside and outside the surrounding houses for the past 20 years. And we thought that it could be a reassembling place for these potential activities that had already existed around the area. This is a site and building layout plan. The site is tangent to the north and south path, and initially functioned as the main lines of the flow from one path to another. There was a single mango tree in the center of the site, which was also grazed by cattle and other animals. While ensuring the flow of traffic in the area, roofs were arranged to provide shading over the entire site, and some parts of it are used as classrooms, closed off by wall and doors. The basic module for each unit has a 5 meter by 5 meter planche, which is the size for the classroom with 20 students, and each unit faces different directions while linking to each other. The colored areas are enclosed spaces. Classrooms are yellow, green are staff rooms, kitchens, libraries, etc. All other areas are open spaces. There are units between classrooms with only roof and no walls, which become a circulation area, a resting place, and extension of classrooms when the doors are open or the stage during events. The picture shows the assembly for a small group in the morning. The classroom is open to neighboring units. This shows how it is used for events. The external space under the roof can become a stage. The roof of each unit have a shade and seating, and the rainwater from each roof flows from one roof to another, eventually being stored in the rainwater tank installed underground. The rainwater flowing from the roof of the neighboring units flows onto the next neighboring roof and through the gutter into the rainwater tank. The ridge on the roof takes the diagonal line of the classroom units, which corresponds with the landscape. This video shows the students at the recess running around, invited by the landscape. The steps and ramps absorb the difference in elevation of the sloping side while forming dynamic steps, making it a place where school life spans both indoor and outdoors, enjoying the change without being canonical to the classrooms. In regards to the construction methods, the repetition of units of the same module was easy for the local carpenters to understand, and the quality improved little by little through repeated construction. On site, we communicated with the carpenters based on the physical models and other materials. Steel hardware is being attached to eucalyptus log posts. Construction was carried out using locally available materials and techniques, including the use of rattan for fittings, which is normally used for furniture. The building experienced a lockdown shortly after it opened in 2020, but the children's voice has come back now. The boundary walls are permeable and, as shown in this photo, follows a zigzag line along the landscape, creating many small pocket space on the periphery. The client has been active for over 20 years now, and today they themselves have become embedded in the surrounding community. The architecture was intended to become such a place as well, where it's not just a gathering place for students, but also an architecture which the inside and outside of the site contribute to the surrounding community.
Thank you very much for listening. I look forward to seeing you in person one day.
All right. So all the way from Japan to Holland. I was just trying to find a link between, Japan and Holland.
Hello?
Over to you.
Thank you very much. Good afternoon. I'm going to, are we seeing the presentation? I'm going to talk to you about two school campuses that we did. They were designed and constructed concurrently, so I'm presenting them basically as one. They were developed by an Australian organization called Cotton On Foundation. They are also in the room, some of their representatives, and both campuses are in Rengo district, a bit west of Masaka. This project was developed in the direct aftermath of the COVID pandemic, and a lot of the principles that were applied in this design by the client, or should I say the way the brief was adapted, can really be explained in that way. Maybe to mention that Local Works has been working with Cotton On Foundation for 10 years, and we've built quite a number of schools, maybe a total of 20 schools or so with them, and it is actually a very rare opportunity for an architect to keep working with the same client and to build similar schools all over again and developing them gradually. So this is something that there's almost like a standard Cotton On design that has then gone through generations of improvement, and that is an incredible opportunity for us as designers who normally are used to working on one-offs. I'm not going to go into too much detail on these site plans, but just to explain to you that the client decided, these were existing schools, and the client decided that schools of 1,000 students are just simply too big. And they therefore decided to break them down into 3 campuses. So each campus actually consists of 3 campuses, one for kindergarten, one for younger primary, and one for upper primary, and that is reflected in these site plans. The other notable difference between the two sites is that the Busibo site, the one that's shown here on the left, had some existing buildings that we converted, whereas the Namabale site was almost a greenfield site, barring 2 buildings that we accommodated within the design. These are some images of the sites, both quite steep terrains, especially the one in Busibo, particularly steep. Quite a lot of existing trees that we obviously wanted to accommodate, and then, as I mentioned, some buildings that we accommodated and refurbished. Some of our experience in refurbishment is quite interesting from an economic point of view. We have found out together with the client that at times refurbishing is actually more expensive than building new, and the decision to refurbish is very often taken out of a sustainability consideration more than out of an economic consideration, and potentially also out of a certain romantic idea of preserving existing buildings that may not always deserve to be maintained. I'm going to sort of talk you through a little bit of a typical classroom design. I've mentioned it has undergone some significant evolution over the years, but sort of the bare bones of it are really that of a very, very simple rectangular classroom block with loads of light and air, a simple exposed roof frame, no ceiling, but lots of ventilation built into the roof and built into the window design. There is a covered walkway on one side of the building. The first generation actually had covered walkways all around the building, which was of course very nice and very luxurious, but also not particularly efficient. If you think about it, I think all school designers who work within this typology know that problem. What is always interesting is how you deal with a symmetric roof and an asymmetric floor plan. You have a walkway in front, and you have a symmetric roof across. How do you deal with it? You can see how this design plays with that in a way. If you look at the roof truss, how it is subdivided in a slightly asymmetric way, and then we're using this little vent roof that sort of plays with that subtle asymmetry. The other thing that is worth pointing out is how we deal with daylight. We are obviously, working in a realm where we are very cost sensitive in how we design these buildings. We love playing with skylights. We love bringing a bit of additional light into these spaces. In this generation of the building, we ended up doing a very, very thin strip of translucent sheeting right above the blackboard. You can see that in the picture on the bottom left, which just sort of allows a bit of daylight to wash down the blackboard without causing any sort of heat ingress or discomfort from too much direct light on the desks, etc. Fair-faced brick is the key element. Clay brick, fired clay brick. That is actually something that went through all 3 generations that we have done for these various school builds. We utilize factory brick, not roadside brick. Factory brick from Butende, which is near Masaka, and which is a reasonably sustainable form of clay brick in the sense that they're using coffee husk for firing